Hello, algebra classes. Let's take a look at our last data display in our chapter on data analysis. We're going to interpret as well as make box and whiskers plots. So this is another way to look at our data, how it spreads out, how it clumps together, whether or not there's any data values that are seeming to fall outside of the typical data range, and so forth. So just a general idea of what this box and whisker plot looks like. Here's a general example. So we'll see a box part. This is going to be the middle 50% of our data. Each box will be a quarter of the data because half of a half is a quarter. And then the part that looks like whiskers here at the top and the bottom and the top here, this is another quarter of the data. So each whisker is a quarter of the data. Each part of this box is a quarter of the data, and so all of those fourths together, 4 times 1/4, gives you one whole set of data. You'll notice I have a number line above my box and whiskers plot, and we will always float a number line above. We won't always go by tens. It'll be set up so that we can accommodate whatever our data is. So it could be going by ones, it could be going by fives, tens, hundreds, whatever will accommodate the data well. This is just going to give us kind of the benchmarks for how large or small we make our boxes and whiskers. So we have 5 data points that are going to be crucial for us to understand and to actually include when we make our box and whiskers plot. The smallest number in the data set is going to go here at the bottom of the whisker. We're going to call that the least value. At the other end, the top end, we'll have the greatest value of the data. It will be this point at the end of the whisker. In the very middle of our data, we will have a single number. If there's not a single number in our data because there's an even number of values, then we will average those 2 middle numbers, and that will be our median. And then we'll have what are called lower quartiles and upper quartiles. These numbers will be the number exactly in the middle of this lower half of the data. For the upper quartile, it will be the number that's exactly in the middle of the top half of the data. If there are 2 numbers in the middle, because again, if we have even numbers, we would find 2 numbers in the middle, we would simply average those 2 numbers to get our lower quartile and our upper quartile. So the quartiles actually separate our data into the fourths that we were talking about originally. So the lower quartile here will separate off the lower fourth of the data. This upper quartile will separate the top fourth of the data up here in the top whisker. And then again, our middle 50% of the data will be in the box with our median somewhere inside of that box. So we have a name for the difference between the lower and the upper quartile, and it's called the interquartile range. So we can ask, how far does the middle of the data seem to spread out? And we would subtract the upper quartile minus the lower quartile to get our interquartile range. And that would be the middle 50% of the data, and that might give you more of a general idea of where your data lies if you only look at the middle 50%, because sometimes you get some data values that fall outside of that range that might not be considered completely typical. All right, let's see how this works. Make a box and whiskers plot to display the data below. This happens to be the ages of some family members, and there's 8 ages that are listed here. What we do first is put our data values in order from smallest to largest, 15 to 70, just like we did when we were doing our histograms and our stem and leaf plots. Then what we do, if there's an even number of numbers in our list, we will separate the data values into 2 separate boxes, and the boxes will touch here if there's an even number of values. So I have 4 ages in my lower box and 4 ages in my upper box. Then I look to see if there is just one number in the middle of each of those boxes. If there is, that would be my lower quartile. If there's 2 numbers in the middle, because we have an even number of values in that lower box, we would average those 2 numbers to find out our lower quartile is 22.5. We'll do the same thing up here. There are 2 numbers in this upper box right in the middle, so we'll average both those to find out our upper quartile is 57.5. And the median will be the average of the 2 numbers that are right here where the boxes touch. So the average of 30 and 40 is 35. So that's my median. Next step, set up your number line. I need a number line going from 0 to 70. I included 80 just to go a little beyond where my box and whisker plot is going to fall. It would have been fine if I'd stopped at 70. That's going to guide where I put my numbers. First thing we do is we find the lowest number. That will be the least value in our data set, 15. Put it down, label it. And then I find my highest value, 70. Put it down where it would fall, 70, right here. Label it. Then find your lower quartile number, 22.5. Draw a straight line down and then draw the whisker from your least value to your lower quartile. And make sure that is labeled 22.5. And then find your upper quartile. Draw a whisker from your greatest value to your upper quartile, labeled at 57.5, and draw a line. Then you're ready to draw the actual box. And the last step is to put the median in. The median is 35, so find where the median would fall, be between 30 and 40. You can see why we have to have the number line here to know where to put these numbers. They need to spread out appropriately. So the median is 35, and there is my median bar right here in the middle of my box. So I have my least value, my lower quartile, my median, my upper quartile, and my greatest value. The whiskers, again, are the lower 1/4 and the top 1/4 of the data. And my box here is the middle 50% of the data. Median is the number that is designated somewhere inside of that box. It's not necessarily the visual middle, but in this case it's a little bit closer to the 22.5 than the 57.5. And because we drew a number line to place these numbers appropriately, we can see that that 35, the median, is closer to the lower quartile than it is to the upper quartile. All right, so let's answer some other questions about this particular box and whiskers plot. Let's find the range and the interquartile range of this data. The range will be the greatest value, 70, minus the least value, 15. So the range of these ages is 55 years. From the youngest person in the family, 15, to the oldest member of the family, 70, there's 55 years in between them. The interquartile range will be how far it is from the lower quartile to the upper quartile. And this is the middle 50% of the data. So we have some outside values here of this box. So the more typical range of ages would be this middle 50%. So our interquartile range, known as IQR, is the upper quartile, 57.5, minus the lower quartile, 22.5. That's what I'm subtracting here. And so my interquartile range is 35. So for the typical ages in this family, there's a spread of about 35 years. All right, now we're going to introduce one more idea that we can use when we're creating our box and whiskers plots, and that's the idea of an outlier. It's kind of what it sounds like. An outlier is a piece of data that falls significantly outside of the other data values. A data value that is widely separated from the rest of the data. That's what an outlier is. How do we find it? A data value is considered an outlier if it is separated from the nearest quartile by more than 1.5 times the interquartile range. So you find out how long the interquartile range is. You take half again of that, as much so that you'll have 1.5 times that interquartile range, and you're going to add it to the nearest quartile. If we're looking at a data value that's way above the upper quartile, we would ask, okay, start at that upper quartile, add the interquartile range 1.5 times. Do we actually reach that top value? If the answer is yes, then it wouldn't be considered an outlier. If that number is still beyond 1.5 times the interquartile range, then it would be considered an outlier. All right, so let's see how that works. That might not make much sense yet. Which value, if any, is an outlier of this data set? We're not told what this data means. I've given it to you in order. 4 is the least value, 72 is the greatest value. So the first thing I'm going to do is I'm going to make a box and whiskers plot so that I can figure out what my interquartile range is, so I can find out if there is in fact an outlier. Well, looking at these numbers, you can immediately see with them in order like this. 72 looks way away from the rest of the numbers. It looks like that is a strong suspect number that might be an outlier. So let's see if it is. So here I am making my box and whiskers plot. First, I'm going to box up the lower portion of my numbers and the upper portion. Notice this time, because there was an odd number of numbers in my list this time of values, there will be one number not in either box. It will be the median. Last time the box is touched because we had an even number of values. If there's an odd number of values, you will leave one number outside of those boxes right in the middle, and it will be the median. And in this case, in both my lower box and my upper box, there are 5 values. That means that I don't have to do any averaging this time. The lower quartile will be the number exactly in the middle, 7. My upper quartile will be the number exactly in the middle of this list. So upper quartile is 23. So we only have to do that averaging if we're working with even numbers of values, either in our boxes or in our total data set. All right, so I'm setting up my number line here, and here is my least value, 4. My lower quartile is 7. My median is 12. my upper quartile is 23, and my greatest value is 72. All right, so looking at this, we can ask, is it possible we have an outlier? If the whiskers seem longer than this box here, we're going to suspect there might be an outlier. And this whisker looks way longer, so we're suspecting this might be an outlier. Down here, the 4 definitely wouldn't be an outlier because this whisker is not as long as the box itself. So no outliers down here. Possible outlier up here. Is this an outlier? The long whisker suggests it might be. Okay, let's find our interquartile range to help us decide if this is an outlier or not. Interquartile range is the upper quartile, 23, minus the lower quartile, 7. 23 minus 7 is 16. Okay, now we're going to ask, is this 72, this data value, is it greater than, start at the upper quartile, that's the nearest quartile, and add the interquartile range, 16, 1.5 times. So we're going to do 1.5 times whatever our interquartile range is, plus this quartile here. Of course, if you were figuring out for a possible outlier down here, you'd be subtracting it to find out if it falls below. But in this case, since it's above, we would be adding to see, is 72 greater than the upper quartile 23 plus our interquartile range times 1.5, which is 24? Is 72 greater than 47? Well, yeah, quite a bit more than 47. So since this is a true statement, yes, 72 is an outlier because it is more than 1.5 times the interquartile range above the upper quartile. So it is an atypical data value in this set. All right, that's all for our box and whiskers plots, including our interquartile ranges and our outliers. So now it's time for you to begin on the homework for this data display, box and whiskers plot. And we'll see you next time.